What do we do first? Nikita.
Find the initial concentration of CO2 in reactions.
Yes, so let's find the initial concentrations, and they are
1.94 moles per liter for CO2,
0.94 and
1.74 moles per liter.
so this is our initial. So you know you need an ice table. Initially, there's 0 products. So, Lexi, what is our change in our ice table going to be?
The first two are x, negative x, and then the other one's x and x.
Okay, so here we've got 0.94 minus x, 1.74 minus x, x, and x. See, this is kind of a tough question because right now, 2 things you know. You're not going to be able to take the square root of both sides because these 2 terms are not the same. Nor can you make the assumption because that's not going to be small enough. So you have to use the quadratic. Yeah, which kind of sucks. Not going to lie. So you would set it up. KEQ is equal to carbon monoxide to the first order, water to the first order, over CO2 to the first order times H2 to the first order. So let me tell you right now, there is, were you given the equation? So you've got 1 mark for this line, 1 mark for this line, 1 mark for there. You haven't really done any major calculations yet, but you've already got 3 marks. So don't skip the small stuff. All right, so plug in your values. 0.74 is equal to x over x, times x. So now we've got 0.94 minus x, 1.74 minus x. So unfortunately, you've got to FOIL this. You've got to work it out and then use the quadratic. Did you get 2 roots?
Yeah.
So only one of them will work, right? Did you get the same root as he did?
Yeah, but then I did the final, the equilibrium concentration, because that's what I thought I would.
So we have these quantities of solutions, and it wants to know, would a precipitate form? So what you have to do is write out your double displacement reaction. So these are 2 solutions that we're mixing together. So we have calcium chloride and sodium sulfate. And they will make sodium chloride and calcium sulfate. Which one's the solid? You've got a 50-50 chance of getting it right. What does your gut tell you?
NaCl.
You are incorrect.
PaHeA-SO4.
Group 1, well done, Tamara. Group 1, soluble. Okay? So what you have to do now is, if that's our solid, this is going to be our equilibrium portion. because we're talking about equilibrium of solubility. So are the ions and the solid going to be in equilibrium? So we know this information. We know this information. We're missing a piece of information. We're going to be comparing Q, which is a trial KSP, to the KSP value. Did I give you the KSP? No. So look it up in the back of your book. Look it up in your appendix. You're going to figure out if your Q is greater than that. So Q is going to be equal to, that's your trial KSP, the calcium concentration times the sulfate concentration. So what you have to do is plug in the values for that and compare your answer to the KSP. But this is the tricky part. The values that you put in here depend on the new concentrations of those ions. Because the volume, the total volume has changed. So we have a little bit of work to do. Did I change the moles of my substances? No. I changed just the volume, so I've changed the concentration. So we use one of the concentration calculations we did last year. C1 V1 equals C2 V2 because the moles are equal. So there's a situation 1 before you mix the substances, and then situation 2 is after. So you have to do this for both ions. So calcium comes from calcium chloride. It's the only source of calcium in the beaker. So you've got 0.001 mole per liter times 50 milliliters. What is my new volume? Nope. I had 50 milliliters and I added another 50 milliliters. I've got 100 milliliters. So if I divide this by the second volume, I've got my concentration of my calcium chloride afterwards. It's milliliters, but the units are in liters.
What does it say after 0.05?
C2 is
That
equal.
minus C2?
That's equal to.
Equal.
Point one meters on the bottom.
Because this is 100 milliliters,
That's on the middle. Oh,
right? Our final volume is 100 milliliters.
You have C1, V1, V2. You're moving the V2 down here.
So we can isolate.
This is the volume that you're isolating with, yeah.
Yeah. Okay, so how many
Honestly, I think
moles per liter do we have?
5 times 10 would be 3.
Yeah. Oops. So C2 equals that's sodium sulfate. How many sulfates are in sodium sulfate? 1. So you would multiply this. This is the tricky part. If you have an ion where there's 2, you've got to remember to multiply it by 2. So this is sodium sulfate times 1 sulfate over 1 sodium sulfate. If you don't do that, let's say I was looking for the sodium ion concentration, I would have to multiply this number by 2 because there's 2 sodiums for every 1 sodium sulfate. So you've got to do this step right here. So what number do you get? What is 0.0005 times 0.005?
2.5 times 10 to the negative 6.
2.5 times 10 to the negative 6. That is our Q. Is Q bigger or smaller than our KSP?
Smaller.
It's smaller. So do we get a precipitate or not? Sorry? No, it's unsaturated. So no precipitate.
Maybe I have to speak louder.
You do.
Maybe you should put an in front.
Unsaturated. So no precipitate. Okay, I want you to try the rest of the questions from the other side.
That's all we have to write for a
Answer.
CAF and NA, another 3.
Okay. So you've got 100 milliliters of this. The concentration is this. 200 milliliters of this. Concentration. Which one is the solid product? Again, 50-50. CAF2. All nitrates are soluble. So this is your reaction that you're going to be investigating.
On the test, would you like you would tell us to know, like you would expect us to know which one was solid?
Yeah, because you have a solubility table.
Oh, like on the.
Yeah, on the back of the periodic table.
So how would you?
Or I would tell you.
Okay, so how would you determine, like, what would the difference be between those two on the back of the periodic table?
Well, it says under nitrates that they're all soluble.
Oh, okay, so if it says it's soluble, then it's
AQ.
Okay.
Yeah. So you have to do,
Go write another Mr. Squid.
you have to, you have to do, it sounds like we have some monks in the building. We have to calculate the final concentration after you mix those two together. Do it now.